Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. Live lesson, A-level maths, yet 2, pure maths. Today's lesson is area of a segment. If you're following through in the book, it's chapter 5, example 14 of the UK A-level Edexcel book. Okay, just a quick recap on some GCSE maths and a little bit of A-level year 1, which is the area of a triangle. The standard formula is half times base times height, but then at more advanced GCSE level, you learn another formula. So if you know two sides of the triangle and you know the angle in between, then the formula for this triangle is area is equal to half AB sine C. So half AB sine C. And this is a really good formula because the triangle can be any kind of triangle with the half base times height formula, then that's restricted to right angle triangles. But this one would work with any triangle. Half AB sine C. And you can have the angle here in degrees or radians as long as your calculator is in the right mode. And then let's look at what we did in a couple of lessons in the last lesson where we had the area of a sector. So if I just remind you what we did there, we had a center of a circle and the radius comes out from the center, and then we draw an arc. So now we've got a sector of a circle. I'm just going to have to do it very roughly here. Again, we've got an angle at the center. Let's call that theta. And then we can work out the area of this sector. There is a long formula, pi r squared times theta over 2 pi, but it shortens to area is equal to half r squared theta. So now let's go to the next step and let's try and combine these two formulas in the next shape. So here what we've got is, let's start with the circle. Let's go from the radius and make a sector. And then what we'll do is we'll split that sector using a straight line from one edge to the other edge. So now I've got this little segment just in this corner here. So in gray. So that's called a segment. The whole thing that I'd made, like the pizza slice, that's called a sector. But then when I cut out the triangle, then what I've got left is a segment. So to work out the area of this segment, what I can do is take the area of the whole sector, so that big pizza slice, and then take away the triangle. So let's put some angles and measurements in there. So we've got theta as the angle here. Remember that theta is the same angle for the whole sector and the same theta for the triangle, one corner of the triangle. And then I've got, because this is extending out from the center of a circle, then both of these are the radius. So for the triangle, I've got what I need. I've got the two sides and I've got the angle in between. And for the sector, I've got what I need because I've got the theta and I've got the radius. So the formula for the sector would be half r squared theta. Can you remember the formula for the triangle? It's half AB sine C. So for A and B, I'm going to use R, so that's half R squared, because A is R and B is R as well. And then sine theta would be just a bit to add on at the end. Sine C would become sine theta. So if I take the top formula and then take away the bottom formula, that's my area for the segment. So that becomes half R squared theta to begin with, and then you're subtracting half r squared sine theta. But then what you notice is that this would be the area of the segment. But then what you notice about this formula is that it's got a couple of factors that are repeated. So you got half and a half that can be factorized to the beginning, and then you got r squared as well. So if you do a bit of factorizing, then this formula can just become a little bit easier to read. So you have the area of the segment is equal to half r squared times theta minus sine theta. And when I was doing A-level maths myself and kind of that level, then I wouldn't bother memorizing this formula. I didn't even know this formula existed because I would always be confident that I could do it from the basics. I knew how to work out the area of the sector. I knew how to work out the area of the triangle. So I could solve every problem, every question that way. But now I realize actually there is a benefit to learning this formula because some questions you're not going to have all the information. So you need to be able to set up an equation where you've got some of it, but there's missing maybe one bit of it, and you don't know what that bit's going to be. So it's always easier to just start with that whole formula, fill in the bits you know, and then you can solve it to work out the bit you don't know. So that's a good formula to remember. Okay, let's try and use that with an example with some numbers. So on the next page, we have example 14 from the book, where we've got the sector, then we've cut out the triangle, and in yellow is the segment we want. The radius is 7, and the angle in between is 1.2 radians. So let's see if we can use that formula now with some numbers from that picture. So here we're just going to use the formula just like it is. Area is going to be equal to, let's take a look at what we're going to use. For the radius is going to be 7, and for theta it's going to be 1.2 radians, and for sine theta, sine is just normal sine, and theta is going to be your 1.2 radians. So let's try that. We're going to have area is equal to a half times 7 squared, which is the radius squared, and then times by, and then in brackets we've got theta, which is 1.2, minus sine theta, so that's sine of 1.2. And then if you type that all into your calculator and then get the answer, you will get, let's just check that. Okay, this calculator is slightly difficult to use compared to your normal calculator, so don't copy too much what I'm going to type in. But on your own calculator, you should be able to do it a lot exactly as you see it. So you'll have a half typed in times by 7 squared, which is 49. You can just type in 7 squared. I've just typed in 49 to make it easier. Times by, and then in brackets, you've got 1.2 minus, and I just need to change that to radians. So that's sine of 1.2. And close the brackets. And you have your answer of 6.565. Normally, you want to write the whole number with a couple of dots to show the number carries on. And then generally, the rounding in the exam is to 3 significant figures, so 6.57. Okay, join me tomorrow for more on radians and circles and segments. Assalamu alaikum wa rahmatullah.